So for this one, let's do chapter PE number 3. So we're trying to solve these inequalities, but we're not doing sign charts here. Well, you can if you want, but we're going to do them graphically. So what I'm going to do is you can do part A and part B two different ways. You could graph like for part A, y1 equals x squared plus 9 and y2 equals 6x, and then just look at the graph and try and figure out, well, when is y1 below or the same as y2? But I prefer to do this where I get everything on one side and just deal with zeros because I just think that's easier for me. It's up to you how you want to do it. So when I do this, I got x squared minus 6x plus 9 is less than or equal to 0. So I'm going to come over here and let me graph this. So x squared minus 6x plus 9. And then I'll do zoom standard. So the negative 10 to 10 window dimensions. Okay, so there's my graph. Now it looks like there's a 0 right there, so I'm actually going to zoom in on that. So let's come over here. I'll move the cursor over a little bit and zoom in right here. There's my graph. Okay, it looks like it goes right through 3 there. So I'm going to check it by doing second calc 0. Left bound, well, this is 2, so I'm going to say 2 there. This number over here is 4, and I'm going to guess that it's right at 3, and sure enough it is. Okay, now I noticed some calculators for students, you're getting stuff like 2.999999997. So you got to realize the calculator is doing an estimate because it can't actually calculate this exactly. It doesn't do algebra, it does other tricks. And so it's actually, when you have something with that many decimals that are so close to 3, like 3.000001, you just have to know that's 3. So I'm going to draw the picture of my graph. So here we go. Looks kind of like this. There's 3 right there. Let's look at my dimensions here. So window, it's roughly, well, really this window is going from about -1 up to, let's say, 6 or so. So -1 to 6 by, and in this case, let's see, -2.5 to 2.5. I think mine is more like -2 up to about 4. So remember, these are the x values, these are the y values. Okay, whoops, let's go back to graph. So I'm looking at when is this curve, this parabola that I just graphed, when is this thing less than or equal to 0? Well, it's never negative. It's always positive or 0. So it's never less than 0. But it is equal to 0 at one place, right at 3. So my answer is going to be x equals 3. Now you can also do this if you like sign charts, and eventually you're going to have to like them. Well, I guess you don't have to like them, but you have to do them. You could make a sign chart, but you don't need to plug in something to the left of 3 and something to the right of 3 because you're staring at the graph. On the left of 3, it's a positive value because it's above the axis. And over here, it's still positive. It's never down here. So if you made a sign chart, it'd be plus here and plus here. So it's never less than 0. It's only equal to 0 and greater than 0. So the only time that it's less than or equal to 0 is at 3. So the way you would write that, I would probably just write x equals 3 for my answer. There's no way to do like an interval notation because this doesn't really mean anything. So if you wanted to use notation that's similar to that, then the correct way of doing it is to use set notation and just say 3 in there like that. So you could do that, but really I would just write x equals 3 and be done with it. For the second one, we've got 2x cubed plus 2x is greater than 5. So again, I prefer to get everything on one side. And now I'm looking for when is this thing on the left, 2x cubed plus 2x minus 5, when is that positive? Okay, so let's go back to y equals. I'm going to clear that out. 2x to the third plus 2x. Oh, gotta be careful. Now, this picture is not going to look right because I'm zoomed in a weird way. So I'll try standard first. Zoom standard, zoom 6. And that looks decent enough to me. So here's my graph. I'll graph this in blue. Kind of looks like this. Remember my window here, since it's the standard window, it's negative 10 to 10 by negative 10 to 10. The important feature is, well, when's it actually hit the 0, right? So I'm going to go second calc, option 2. It's already on the left of the 0, so I'll just hit enter. I'll scroll over this time. So that's on the right of the 0, and then I'll just kind of move it about there and guess that's the 0. So the 0 ends up being 1.1147, let's say. If you wanted it around to 3 decimal places, 1.115. Now, you don't have to make a sign chart, but if you really wanted to, here it is. Here's the 1.1147. That's a 0, x. Now, if I'm on the left side of that on the x-axis, it's all below the y-axis, so it's all negative here. And over here, it's all positive. And what I'm looking for is, when's it positive? Okay, well, it's positive from 1.1147 onto infinity. So my answer is going to be this. Up to infinity, not including the 1.1147. You could also write that as x has to be bigger than 1.1147. Okay, all done.